In this video, we're going to solve another practice question, question number 12 from chapter 11, which is about the timing of buying, selling, or holding the inventory. So I have the question here. The Atlantic Seafood Company, ASC, is a buyer and distributor of seafood products. So they want to decide when to buy seafood, when to buy shrimp, tiger shrimp in this case, when to sell them in the market, and when and how much to hold per week, right? So our planning horizon is 4 weeks, and we're assuming that they know exactly what is going to be the price of tiger shrimp per pound every week, so they can accurately predict the price for 4 weeks from now. All right. And one assumption in this question is that the price is the same regardless of whether you want to buy or you want to sell at the market, right? So for example, the price at week 1 is going to be 6. So if you buy at week 1 and sell it at week 1, you're not making any profit because you're buying it at 6 and you're selling it at 6 again. You're not making any loss too, because you're buying and selling at the same price. But if you buy at week 1 and sell it at week 2, you're gonna make a it's not net profit because you have a holding cost too that you should consider. But the gross profit is 20 cents per pound of shrimp that you sell during week 2. If you and then if you buy it at week 1 and sell it at week 3, you're gonna make a profit of 1.65, a gross profit. Again, there is gonna be a holding cost that we should consider. But 1.65, the difference between 6.65 and 6 would be the profit that you can, a gross profit that you can make per each pound of shrimp. But again, you have to consider the holding cost as well, because you have to keep the inventory in your storage for 2 weeks. So you have to keep them safe and protect them, right, during that 2-week period. All right. So the company, one of the, so they have, you have all these details. The company has currently 20,000 pounds of tiger shrimp. So it's very important to just focus on one unique measurement scale, which is in this case is going to be our measurement unit is going to be pounds, and our product is tiger shrimps, right? So they currently have 20,000 pounds of tiger shrimp in storage. The space is available. The maximum space that they have available is going to be 100,000 pounds of tiger shrimp. So you can't buy more than, let's say, if you have 20,000 available right now and the storage capacity is 100,000, you can't buy more than 80,000 just to store in week 1. If you want to buy and store for week 1, you can't go beyond 80,000 because you currently have 20 and the maximum capacity is 1,000. And if you keep 100,000 for week 1 and you decide not to sell it in week 2, you won't be able to buy anything else because you already are 100% capacitated. You have the inventory, the capacity that you have, the storage capacity is 100% full. So you won't be able to buy anything if you don't have any available storage capacity. All right. So that's very important. So moving on, we have the price, and we want to know what would be the optimal buying, storing, and selling strategy for the next 4 weeks, assuming the prices are fixed. There's going to be a holding cost of 15 cents per pound. And to account for unforeseen changes in supply and demand, management also indicated that 25,000 pounds of tiger shrimp must be in storage at the end of week 4. So week 4, the demand, the actual inventory should be more than or equal to 25,000. Determine the optimal buying, storing, selling strategy for the company. What is projected profit? All right. So, and then there's a hint at the end. Define variables for buying, selling, and inventory held in each week. Then use the constraint to define the relationship between these, which would be inventory from the end of previous period plus bought at this period minus sold this period is going to be equal to inventory at the end of this period. This type of constraint is referred to as inventory balance constraint, right? So just to understand, just to really very quickly determine the um, inventory inventory balance constraint, I'd like to come here and then show you something. Let's say this is you know we just said we have a storage capacity of 100,000. Let's say this is our storage, right? This is our storage container, for example, and it's good for, let's say, a maximum of 100,000 pounds of shrimp. That's the storage capacity. So this is 0, this is 100,000. All right. So if you put shrimp all the way from here, all the way to the tip of this container, you will have 100,000 pounds of shrimp. But then right now we have 20,000. All right. So I'm going to call this I inventory 0, which is our starting inventory, initial inventory. If I buy during week 1, I'm just focusing on week 1 right now. So I had 20,000, and let's assume that we make a purchase of, let's say, 60,000, for example, during week 1. So I make a purchase of B1. I'm not going with numbers because I want to understand the relationship here. So let's say we had this much in the beginning of the period. We bought this much during the period. And then, so this is the total amount available during the week to be sold out to the customer. But then let's say we sold during the week this much, S1, I call it S as for sales, and 1 for week 1. Let's say if we sell during the week 1 this much, our inventory level at the end of the period is going to go down from here to here. And this is going to be my inventory level at the end of the period. So I had this much, I bought this much, my inventory level went up to this level, and then I sold a little bit. I sold whatever amount up to this much, up to this amount I can sell. Let's say I sold equal to S1. So my inventory level at the end of the period is going to be I1. So if I want to write down the inventory balance constraint, this is a logical relationship. It's always true. So I0 plus B1 minus S1 is equal to I1. Or if I want to generalize it, I can add index T, and I can have I T minus 1 inventory at the end of previous period, or inventory at the beginning of each period, plus purchase during each period T minus sale during each period T is going to be equal to inventory at the end of period T. So I have to respect this inventory balance constraint for each period. So now let's go back to our question here. And let's go ahead and formulate this problem. So there are 3 types of decisions that we have to make in each period. So I'm just going to go ahead and write it down, decision variables. So in each period, we need to decide about how many items, how many pounds of shrimp to buy, how much to buy at period T. And I'm going to call it B of T purchase. And it's going to be, in this case, it's going to be B0, B1, B2, and B3. B1, B2, B3, and B4. So that is going to be the amount. How much to buy? Let me just change it to amount of purchase of shrimp at period T. So that's one thing. And then I have 4 of them. And then amount of sale of shrimp at period T, and I'm going to call it S of T. All right. And then I also, based on the model that we just talked about, we have B purchase, buy, the amount that you buy, the amount that you purchase. We have the amount that you sell. And there's also another thing that even though we don't necessarily decide about, but it has a crucial role in our model and in our decision making, right? Because you can't really, so these are really important. You have to really keep an eye on these. Inventory levels. Because of that, I'm going to define them, and we have to have them in our inventory balance constraint. So let me just go back here, and I just add inventory level at period T again, and I'm going to call it IT. And then I1, I2, I3, I4. All right. So these are my decision variables. Now, objective function. So objective function would be to make as much as profit that we can make here, determine the optimal buying, storing, selling strategy for ASC. It didn't say specifically, but then the question right after it, what is the projected 4-week profit? And then profit is our objective function, the total profit. So the total profit, and this is something that we want to maximize, objective function to be maximized. And it would be, you can put max before total profit, or you can put it right after here. So total profit is going to be our objective function. But what is the total profit? How do we characterize profit? So there are 3 things actually at play right here. But then, and then for sale, when you sell something, your revenue is realized. When you buy something, you have a purchasing cost. And when you hold something, you have, when you hold something at the end of each period, you have a holding cost. All right. So total profit is going to be revenue of sales plus revenue or sales actually, which is coming from the SD, and plus, and actually there is no other revenue item, there's going to be two costs, purchasing cost revenue or sales minus purchasing cost minus holding cost. So that is our objective function. Revenue or sale is going to be the amount that you sell at week 1 times 6 plus the amount that you sell at week 2 times 6.2 and so on. Remember, our assumption was that the selling price versus the selling price and the buying price is the same. It's just we have a reference price and it's going to be the same regardless of whether you're buying or selling. It's going to be $6 in week 1. So that's something that you want to consider. So let me just write it down. Assumption prices are the same for buying and selling. Let me just add it here. All right, assumption prices, weekly prices are the same for buying and selling. Right, so this is may not be necessarily true in practice, but that's our simplifying assumption. All right, so we have objective function, and let me go ahead and write it down, or at least a little bit of it. The total profit revenue is going to be 6 times the price per pound in week 1 times the amount of sale at week 1 plus 6.2 times S2 plus so on, 6.65 times S3 plus 5.55 times S4 plus, so that's for sale, that's for revenue, and for purchasing costs, I'm going to put minus parenthesis, and then purchasing costs. So if I buy at week 1, I have to pay $6 per pound times B1 plus 6.2 B2 plus 6.65 B3 plus 5.55 B4. And I'm not going to write them down because I have limited space here. But anyway, so it's make sure to put negative here because this is cost in our profit function. So revenue minus total purchasing cost minus the holding cost. So the holding cost, we just said that there's going to be a 15 cent per pound of shrimp. If you that's going to be our holding cost, storing cost, right? So, and then how much are we keeping in the stock? I1 is going to be the amount that you keep from week 1 all the way to week 2. I2, I3, I4. So I'm going to define my holding cost based on the at the end of period inventory level. So minus $0.15 times sum of inventory. I1 plus I2 plus I3 and I4. I just thought that I'm gonna write it. Okay, I can write it down for the other one, but it's, let me just write down 6.65 S3 plus 5.55 S4. All right, and then for B, same thing for B, for purchasing cost. All right. So that this is now our objective function. And again, make sure to have positive for revenue and negative for purchasing costs and holding costs. All right. So now that was our objective. Now, what are the constraints? We have, we need to first make sure that we have the inventory balance constraints. So that's one thing. The second thing that we have to respect is this, the maximum storage capacity is 100,000 pounds of tiger shrimp, which should be respected. And this one, we have to make sure that we have 25,000 at storage at the end of week 4. So this is actually our I4. We have to have at least 25,000. So I'm going to go ahead and write down the inventory balance constraints. So constraints, let me just go item by item. Inventory balance constraints. So for each week, I have to have the constraints that we just defined. This one, inventory at the beginning of period plus purchase minus sales equals to inventory at the end of period. All right. So for week 1, and then we have to have it for 4 weeks. So the left-hand side is going to be inventory at the beginning of period. Inventory at the beginning of first period is 20,000. It's actually 20,000 plus inventory at the beginning plus purchase at week 1 minus sales at week 1 equals to inventory at the end of period 1. All right, so, and then next, I1 plus B2 minus sales at second period equals to inventory at the end of second period. And just keep doing this for the other one and the next one, but just make sure to update the T. So this is I2, 3, and 3, and 3, and this one, this should be 3, this should be 4, and 4. All right. So this is inventory balance constraints for, and then we have it for each week, making sure that the logical relationship between inventory, purchase, and sale remains. The logical relationship is maintained. So that's what you want to have, right? Next thing that you want to have is that you don't want to go over the storage capacity. You don't want to violate that assumption, right? So inventory storage capacity. Each I inventory at inventory T, I just put IT, we just call it IT, should be less than or equal to 100,000 pounds. For T equal to 1, 2, 3, and 4. That's another thing. Yeah. Next, we need to make sure to have I4 should be greater than or equal to 25,000. So inventory last end of week 4 inventory. I4 should be more than or equal to 25,000. All right. So these are the assumptions. And these are the constraints. So we have decision variables, 12 of them, right? So 3 types of decision variables, 4 period, 3 by 4, 12, objective function, and then the constraints we have 4, 4, 8, and 1, 9, 9 constraints in total. And let me just go ahead and um, solve them. So we have decision variables. Let me just calm down. Or let me just put it right in front of this. We have decision variables. We have, doesn't matter whether you want to have weeks on rows or weeks on columns, but you have to define each one of these in 4 weeks, right? So what I'm going to do, I'm going to just put these right here, and I'm just going to, just to save a little bit of space, I just add week 1, week 2, week 3, and week 4. And then these are going to be these 12 cells are going to be my decision variables. All right, so we have amount of purchase of shrimp at period 1, at week 2, at week 3, at week 4, and then amount of sales at week 1. It's better if you, let me just do it, sorry, let me just do it separately and do it right after this, because I want my formulation to be separate. Okay, and then amount of purchase, amount of purchase of shrimp, or, and then, yes, I just put buy, sell, hold. So this is the amount. This is my decision, and this is the week. So this would capture all my decision variables. How much to buy, how much to sell in each week, and how much to hold at the end of each week. And that would capture my decision variables. Now for objective function, profit, I have, let me just write down the weekly price, the price per pound of in each week. So the list of, I just put it right here. Since I define my weeks in rows, I have to just convert this also, transpose it, have it in rows as well. So price per pound, it's 6, 6.2, 6.65, and 5.55. So that's my price. This is the list of parameters that I'm keeping here. And also, let me just write down 1,000. I can add that one, and also this one. I can add those later, but this one, it's probably better to have those. So we have the, this will apply to both buy and sell. And let me just have that holding cost per pound would be 0.15. All right, holding cost per pound is 0.15. Now, the objective function, the total profit, we just defined it in this way. The total revenue. Total revenue is going to be the amount of sales, the amount of sales multiplied by the price. So how much do you sell for how much do you sell, right? So let's say this is going to be this is going to define, this row is going to define the volume of sale, and when you multiply them by corresponding selling price of each week, you will get the total revenue. So I'm going to go ahead and use some product function, how much you sell and at what price. So that would define my total revenue in during a 4-week period. And then minus purchasing cost. Purchasing cost is going to be, again, the price per unit multiplied by the purchase amount, right? And then again, I'm going to use some product, the amount of purchase, the price of purchase, which is the same as we had this assumption. Prices for purchase and sale are the same. And then minus the holding cost, minus the holding cost. And holding cost is per unit is fixed, is per pound is 0.15 cent. $0.15 or 15 cents. It's going to be 15 cents times sum of I1, I2, I3, I4. So that is going to define my objective function. Right? So, and it's like I said, it's the amount of sales and multiplied by the purchase price minus the amount of purchase multiplied by the price minus the 15 cents times the sum of inventory. So that's the end of my formula for the objective function. And the only thing that is left is going to be the constraint. I have to first define the inventory balance constraints. For those, I'm gonna come back here and write them right in front of the constraint. So I have a left-hand side and a right-hand side for each one of them. So the LHS is going to be, for the first one, it's going to be 20,000 plus the purchase at week 1, right? Yeah, the purchase. No, I just noticed that I have defined my weeks in rows here and then here in columns. So it's probably not a good idea to write them in front of them. Let me just get rid of this, and because doesn't really matter. But it's, since I defined it this way and I'm gonna drag my formula to the right, it's probably better to define it in a different format. So I just, I'm gonna come back and I'm gonna use this. I'm gonna use my row, my weeks in written in a row, and let me just go down a little bit. All right, so I'm writing down the inventory balance constraints. All right, inventory balance constraints. So for each one, we have a left-hand side that should be less than or equal to a right-hand, should be exactly equal to a right-hand side. All right. So the left-hand side for week 1 is going to be 20,000, the starting inventory, plus the purchase at week 1 minus the sale at week 1. So that's my left-hand side. And this should be equal to, this should be exactly equal to RHS, and RHS in this case is going to be the amount that you hold at the end of week 1. And that defines my inventory balance constraints for week 1. All right. Starting inventory plus the amount of purchase minus the amount of sales is equal to the end of period inventory. And so let me just write down for the second week. I'm going to drag my formula, except that this 20,000 should not be 20,000 for week 1. It should be starting inventory for week 2. And a starting inventory is going to be the amount that you hold at the end of week 1. So this is the actual function. And then I can now drag it to the right. All other parts are good to go. So let me just make it a little room here. All right. So let's say for week 4, I said the inventory at the beginning of week 4, which is the inventory at the end of week 3, plus the amount of purchase at week 4 minus the amount that you sell at week 4 should be equal to the amount of inventory at week 4 or 29. Wait. Wait, sorry. You hold and then yes, that's correct. No, that's good. Sorry. So that would capture the inventory balance constraint for us. So that's one set of the constraints. We also have the inventory storage capacity, and we also have end of week 4 inventory. So decision variables, objective function, the first set of constraints, and then the second set would be very easy. We just need to make sure that these 4 are less than or equal to 100,000. So I'm just gonna come here. Inventory storage capacity, and then again week 1, 2, 3, and 4. And then inventory at week 1 should be less than or equal to 100,000. And again, I can just drag it to the right. Let me just change the font color for this one, and then let me just make it a little nicer. We didn't need to really write it separately. We could have simply add this to our solver rather than just typing it here. In our solver, you need to make sure to have these 4 less than or equal to 100, and it should be 100 here. Let's make sure to stick to 100. All right. 100,000, yes. All right, that's the inventory storage capacity. And our last one would be end of week 4 inventory, and that would be the inventory at the end of week 4 should be greater than or equal to 25,000. All right, just let's quickly review our spreadsheet model. We have the decision variables, 12 decision variables. We have the objective function, which is the profit, which is the total revenue minus the purchasing cost minus the inventory holding cost. And then we have three sets of revenue, three sets of constraints. The first one, inventory balance constraints. For each week, we need to make sure that the initial inventory plus or inventory at the beginning of the period plus the amount of purchase during the week minus the amount of sales during the week should be equal to the amount of inventory at the end of the period. And we need to define it for all the 4 periods. Next, we have inventory storage capacity. We need to make sure that the inventory at the end of each period, not to go beyond 100,000 pounds of inventory, which is the storage capacity for our inventory level. And also we need to make sure that the inventory at the end of week 4 is enough, which should be greater than or equal to 25,000 pounds of tiger shrimp. All right, so now our model is, spreadsheet model is ready. Let's go ahead, go to the data tab, solver, and let's go ahead and solve it. So we want to maximize the profit. We want to maximize the profit by changing the 12 decision variables. All right. Subject to, let me just put it here. Subject to add. We want these 4 to be exactly equal to the end of period inventory level for each week for all these 4 weeks. Add. We need to have the inventory at the end of each period to stay in the allowable range, to be below 100,000 units. And also, we want to have the end of week 4 inventory to be greater than or equal to 25,000. And you can type 25,000, or if you have it on cell, you can add it. And then make sure to change the solver to simplex LP. And that's it. And I think we're all set. We can just go ahead and solve it. Excel found, like solver, Excel solver found the optimal solution. So let's take a look at what Excel provides. And I'm not gonna really get the sensitivity or answer report here because it just asks for the projected objective. Let's take a look. The projected objective, the projected profit is $12,500. And this is our decision. This is actually our buying, selling, and holding schedule. So at week 1, as you can see, so we already had 20,000 at the beginning of week 1. So we make a purchase of 80,000 and we keep all the resulting 100,000 in store at the end of week 1. So we move on to week 2. During week 2, we don't make any purchase, we don't sell anything. We keep storing all the items that we bought and all the items that we had available, 100,000. We keep storing them and move to the week 3. During week 3, we don't buy anything, but we sell all the items, all the inventory available, which was 100,000. We sell everything at week 3. And at week 4, we make a purchase of 25,000 in order to bring up the inventory level to 25,000 to respect the end of week 4 inventory level of 25,000. So this is based on the numbers that we have. This is the best that we can do. And then the projected inventory, the projected profit level would be 12,500.